Hey guys, welcome back to another problem solving video, and in this video I'm going to be going over Leetcode question 20, valid parentheses. It's easy and we're going to be building up from here. So this question is basically asking us to determine whether a string of parentheses is valid. So for example, if we have something like this, that would be considered valid, and so would something like this. But then if we put like this, now this is not valid because these two aren't a valid pair. So of course you might be thinking that we can just go through the list and check if the one behind it is the correct pair, like so, but you also have to remember that you can do something like this. So you can have a parenthesis inside another parenthesis. This is still valid because these two form a pair and then these two form a pair. So you're not going to be able to just go through each element and just check the one behind it. So we need to think of a better alternative. Now, before we get started with the solution, I first just want to eliminate the edge cases. So the edge cases, or the pretty obviously wrong ones, were just going to be when you're going to have an odd number. So if you had something like this, well, that's obviously wrong. You can tell the length of this is 3. And obviously if you have an odd number of brackets, then there can't be a whole number of pairs, so it must be wrong. So let's just write if length is odd, then reject. So just return false. That's what we like to do in these kind of true or false returning problems. So here's the first edge case. Now we can get started on the solution because there's no other obvious edge cases that we need to consider. Okay, so since we've already seen we can't just look to the previous item like so, because let's go like this, and like if you had something like this, right? So if you are given this string, how are you going to determine it? Well, you might want to sort of count up how many of each type of parentheses there are. So you could count if there's this number of these curly parentheses, and then check if there's the same number of complementary ones, and do the same thing for the square and also the curly ones, I believe. I'm not sure what they're called, but yeah. But then what you'd be missing is the order, because even if it has the same amount, like this one might be moved over here and now it's wrong, but you'd still get it right. You'd still have the same number. So you also need to factor in the order, and that's why I believe for this situation we should be using something like a stack to solve it in the most efficient way. So what I mean by a stack is, let's just say this is our stack. We basically I'm going to move this over here. So what I mean by a stack is we're going to loop through this and we're going to add and delete items into the stack. So put them in and then take them out, like so. Okay, so what this is going to allow us to do is we can basically sign off all each of these parentheses. So for this one, we'd put it in the stack. So let's just put it in like so. And for this one, we'd put this into the stack like so. And again, this one, since these are all open brackets, right, so we're putting them all into the stack. But now you see we have a closed bracket. So when we see a closed bracket, that indicates that we want to actually take something out of a stack, because if there's a closed bracket, then this should imply that there will be the same kind of open bracket behind it. So we want to look at the top item on the stack, which is this, and if it's the complementary bracket, so this is a square bracket, this is also a square bracket, so it's complementary, and we're essentially just going to sign this off. So we can sign off this bracket and then just delete it from the stack because it's been signed off. Now same for this one, we can now look in the stack, check the most recent one, and if it's the complementary bracket, it's the correct one, so we can sign this one off and delete it from the stack. And the same for this final one, look into the stack, check if it's the complementary bracket, and then sign off. So this has been signed off, and so. And once you've done that, if the stack is empty at the end, that means that all items have been signed off, so all open brackets have been signed off, and now that means it's a valid string. So let's try and write this properly. If open bracket, then we put into the stack, and if it's close bracket, then we take it out of the stack. Okay, so there's two cases we need to think about. So one thing we need to think about is if we haven't finished going through the string, but there's still there's no more items in the stack. So what that shows is there's all of the current open brackets have been signed off, and the one we have now is just gone. So what I mean is, if we have like too many close brackets, then obviously we're going to be able to sign off all of the current brackets, the current open brackets, but it's still not going to be valid. So what I mean is, if I put another bracket here, the stack is empty, but we need to check there's nothing here, so obviously there's something wrong. So this is an invalid string. And same kind of situation for if we get to the end and there's still things in the stack, that shows that there's too many open brackets, so it's again not a valid string. So yeah, I hope you can see that we need to have the perfect number of open and closed brackets in order to leave this stack empty at the end. So now that's pretty much it. We can begin on implementing it. So I'm going to just bring up the code. Okay, so let's just put this like this. Okay, so I'm going to be writing this in TypeScript, but let's just take the okay, I've already written up the solution, but it's fine. So what I'm going to do is just put this in, and we're just going to be implementing everything I've said so far. So first we need to remember our edge case. If the length is odd, then we want to reject, and to check if something's odd we just do mod2 is equal to 1, return false. Okay, now the next thing we want to do is we want to implement this stack. So let's create a bracket stack, and a stack is just an array, but like so, and we're going to be looping through this string. So let's just do for const bracket of s. Now we've got the bracket, and we first need to check whether it's an open or closed bracket, because if it's an open bracket we're going to send it into here, and if it's a closed bracket we're going to pop or try to pop. So the way to identify this is I'm just going to and we also need to remember to find complementary pairings. So what I'm going to do is I'm going to create a map of all the closed brackets complementary pairings. So closed brackets complementary pairs. And what I mean by this is, for the closed bracket, like this closed bracket, the complementary open bracket would be that, and same thing for the square bracket, we have an open square bracket, and same thing for these curly brackets, we have these curly ones, the open ones. So now what this allows us to do is, we know the bracket has to be some kind of bracket, so to check if it's an open bracket, it's not going to be a key in this. So if close bracket equals undefined, if that is true, what's wrong here? Flashing implicitly as any, because okay, I think we need to make this let, I believe. Okay, let's just define what this is trying to be. Got a key, and we have a map into a string. Okay, sorry about that. Anyway, so yeah, if this is undefined, I'm actually just going to move this over to here so we have a bit more space. So if this is undefined, then that means this bracket must be an open bracket. So all we're going to do is we're going to put it onto the stack, like so. So bracket stack dot push, and we'll just put the bracket onto that. The ones we're really interested in are the closed brackets, because this is where we actually do the sort of checks, if you will. So if it's a closed bracket, then we need to try and pop the thing from the stack. So if bracket stack dot pop, okay, pop is equal to the complementary to this bracket, or if it's just equal to let me just take this, because remember, on top of the, we're basically looking for if the top item on the stack is the complementary one to this closed bracket. So we're going to try and pop it. If that's true, then we just leave it, so nothing happens there. Otherwise, we're going to return false, because if this is not true, then there's obviously something wrong. So something's gone wrong here. So I'm just going to write if that's not equal to that, and then return false. And one thing you'll notice is if the stack is empty and you try and pop it, this is going to return undefined, and undefined is never going to be equal to this. So we should be able to also return false and deal with that case pretty simply. So there we go. Now the only thing left to do is check if there's still items left in the stack at the end. So if bracket stack dot length is greater than 0, we're going to return false, because remember, it's about that perfect timing thing. And otherwise, we're just going to return true, because it's true by default, and we're just looking for mistakes. Okay, so let's see how this works in the test case they've given us. We'll try this one first, and let's just open up. Okay, actually I can just see if this works over here. Let's just put that in there, and we're going to submit. Okay, so we do actually get a submission, and you can see it's pretty fast because all we're doing is we're looping linear through. So this is O of n time complexity. The memory is a bit bad. I believe that is because of this bracket stack, but it's alright because this is the optimal way. I usually look for time and then memory comes second in priority. But yeah, if you can find any ways to increase this memory or make it better, then let me know in the comments. Anyways, thanks for watching, and this was how you complete question number 20 on Leetcode. Thanks for watching, and I'll see you guys in a future tutorial. Bye.